Hi friends, welcome to Mechanical Explorations. Now in this part we are going to see one of the most important term, that is critical thickness. Before going to this, we need to make sure that we are understanding the concept very clearly, because in this term only we have got n number of questions in GATE. See, first address the diagram. Don't consider this Q insulation without insulation, we will be coming later. First, initially here the heat has been in y axis and the radius in x axis. This RC is critical radius. Initially, before going to these questions, there are three cases. Only in these three cases only every questions will come. Initially, case 1. Here R1 is greater than RC. First you need to know what is critical radius is. See, before going to this, critical radius has a range of 2 mm to 4 mm. This is in general only. I have given in general. If you consider this critical radius as 2 mm to 4 mm, then what R1 radius will be here? You consider a steam pipe. Generally, steam pipe will have a radius up to, generally it will be in meters only, not in mm. When we come to critical radius, it is mm. So when the question is given like steam pipe, the radius is in meter. So obviously it is more than critical. What happens? It is more than critical, right? So you can see here, that is more than critical. It is falling in the second zone. Consider before RC is the first zone, after RC second zone. What happens? It is falling in second zone. You can see the heat, how the heat curve here. The heat loss is decreasing. In the second zone, you can see the heat loss is decreasing. That's why I have given here the heat loss decreases. When you come to the case in which R1 is less than RC, which means the critical radius is more. You can see in this case, that is, this thing falls in the first case, which means that the heat loss, first it will increase and it will reach to the maximum, then it will decrease. See, I have given an example here, it is steam pipe. What the example will come here is electric wire. That's why the electric wire problem is being asked out of 10 times, 9 times it is being asked in GATE. Very important thing, electric wire. Because the electric wire only has a thickness which is less than RC. Here only we have to be very careful, because here only the heat loss is increasing. And then it will be reached to the maximum and then it will be decreasing. You already seen, reach to maximum, then only it will decrease. That's why if they are mentioning in problem like electric wire, you should be very careful, because it will be less than RC. Where any other thing, it will be more than RC only. More than RC, you have been seeing all those things in thermodynamics, because this steam pipe, all those things in thermodynamics. Now coming to heat transfer, we need to address the problems like which are less than RC. So here electric wire is been coming into picture, and you should be very careful, because our understanding is when we insulate anything, the heat loss will be decreasing. But in case of electric wire, what happens? The heat loss first increases and then only maximum. So be careful in electric wires. Now moving on to next thing, and case 3 here, what is the condition for maximum heat flow? See, when we insulate in such a way, it reaches RC only, it will be maximum, nothing. You can see here, that is, when the heat loss will be maximum, the heat flow will be maximum at RC only. This is an important one mark. It has been asked in ISRO, BARC and so many exams. So only this is the 3 case. Wherever in which examination you can take, in this 3 case only, the every question is being asked. So if you are confident on this is 3 case, we can address the problem very easily. Case 3, you just seeing the question, you can tell the answer. What to do for case 1 and case 2 is, initially you have to calculate RC. How to calculate RC? That is, it will be given for sphere and cylinder. The formula for sphere is 2K insulation by H outer. You have to check the problem, and if in case of sphere it is, you have to take the formula K insulation, and you have to see that the K, whether the K insulation is being given in the problem. That is one of the main thing. and H outer will be there, and you have to calculate RC, and you have to compare with R1. If in case of cylinder, you can see that R equal to K by H only. This problems is very easy. If you know this formula, just two formula for a cylinder R equal to K by H and sphere R equal to 2 K by H, you can address the problem very easily. So this is the thing I want to tell. And after finding RC, you come here and you address these things, and you can see the heat loss decreases or heat loss increase and max and then decrease. Now coming to the graph, you can see at RC it is Q max, and now coming to this two things, it is experimentally given. See, they have found out that this 2 points is with insulation and this 2 points that is without insulation. Our exam point of view, what we have to understand and make sure is that I have said that this first zone for electric wire. So what happens? Q insulation is greater than Q without insulation. Same thing, because you can see the graph, right? I have said this zone is for steam pipe. Here Q insulation is less than Q without insulation. Now you can see for electric wire, Q insulation greater than Q without insulation, steam pipe Q with insulation, without insulation. See, this is the thing I want to tell. This is the criteria for electric wire and steam pipe. You can find these things in some 1 marks, and you are given the condition for maximum heat flow, that is R equal to RC. At RC only there is maximum heat flow, and the current carrying capacity. I will be addressing these things, like why the current carrying capacity is directly proportional to heat loss. See, first consider a wire and you are putting an insulation on it. Now if the wire is not losing the heat, what happen? Already the wire is hot and the current is also flowing. Now whether the wire will sustain, it will burn. Now consider if the wire is losing the heat and the current is flowing, then the wire can sustain. What happens? From this I can tell that the current carrying capacity or the current holding capacity is directly proportional to heat loss. These things also some in 1 marks taken as. Say, I have said the concepts also for this current carrying capacity directly proportional to heat loss. And another thing, I want you to check in problems, that is, you need to identify only if the insulation it is from outside, then only it is the concept of critical thickness. Then only it is a question of critical thickness. If there is not said that insulation from outside, then you can't say that is critical thickness problem. You have to identify this thing. We need to see whether it is cylinder or sphere. We have seen the formula. It is 2K by H and K by H, and K insulation by H outer. And we need to check whether thickness asked. If it is thickness, then it is RC minus R1. If it is radius, simply it is RC. So this is a very important topic, and I need not you to lose any marks in this. So please be very careful in addressing all those things. I have given everything. See, this is a derivation, whatever we need these things, and we have taken into account. See, I am coming from down. Like here you can see the cylinder or sphere insulated from outside, and you can see I have been explaining all those concepts. Why cylinder or sphere only we have taken in account? Why not the thing like hollow cylinder and hollow sphere are not taken in account for critical thickness? Let me explain. You can see that here you can see the cylinder, or consider a sphere. This is not hollow, it's a general cylinder or sphere. What you are doing, you are going to insulate from outside. This is due to outside insulation. You are insulating outside. What happens? If you are insulating outside, the thickness is increasing. So already it is this much. Now you have insulated this much, the thickness is increasing. What happens? Next, the conduction, that is if your thickness is increased, the heat loss will be less. Due to that, the resistance is increasing. So the resistance is increasing, but the surface area also increases, which decrease the convective resistance. Convective resistance in the sense that H outer, you have seen that, right? That will be decreasing because it is contacted with surface, right? Like that it will be going. So it is decreasing. So we cannot tell, that is the total resistance, whether it is increasing or decreasing. Total resistance is R conduction plus R convection. What happens? One is increasing, one is decreasing. We cannot tell the total resistance is increasing or decreasing, and it is dependent on both those things. So we cannot comment. Hence, due to insulation, the heat loss may increase or decrease. That's why it is dependent upon thickness of insulation. That's why it is dependent upon the concept of critical thickness is valid. See, heat loss may increase or decrease. That's what our criteria is. Please understand. Heat loss may increase, heat loss may decrease. That is the main thing should be here in concept of critical thickness. That's why this sphere and cylinder are valid. Now coming to hollow cylinder and hollow sphere, you can see you are insulating it from inside. It's hollow, right? You are insulating it from inside. What happens? The thickness, due to the insulation, the thickness increasing, and that increase, the conduction also increasing, and the surface area is decreasing. Surface area is nothing but you know that formula. So that's why I don't want to go for elaboration. It will take time, and it is not necessary also for here. What our conclusion is that the heat loss should be increase or decrease, then only we are taking in concept of critical thickness. Here the heat loss is decreasing only, so we are not taking the concept of critical thickness, and it is not valid also. Same thing in plane wall. You can see you are insulating, the surface area due to insulation and H is constant because plane wall, right? And the insulation thickness will increase. See, due to insulation thickness increase and conductive resistance increase, and whatever your conclusion is, heat loss is decreasing only. So due to this concept, critical thickness is not valid for this plane wall, and we have already derived all those things. See, R total is R conduction plus R convection. Our main problem is to address that whether heat loss increasing or decreasing. That is the main thing. We are getting that thing only in sphere and cylinder, and we are getting the heat loss decreasing only in hollow cylinder and hollow sphere, and also in plane wall the same concept, the heat loss is only decreasing. So the concept of critical thickness is not valid in plane wall and hollow cylinder or hollow sphere. Only in cylinder and sphere only the critical thickness concept is being valid. So that's why only we are considering in critical thickness in cylinder and sphere only. Cylinder you can see that K insulation by H outer, and sphere nothing but 2K insulation by H outer. There is a thing I want to tell, and you can see K insulation I already stressed that you should see whether the K insulation is given in the problem, and that is from outside, then only it is termed to be concept of critical thickness will come into picture. We neglect this diagram for time being. Right now we will be seeing in problems so that you can understand very elaborately. Take these things as a notes, very important, and hope so you understand this concept very clearly. It is very much useful in every exams. Like this three cases is the soul for this problem and this concept for solving, and we have to check these things only. Hope so friends you understand all those concepts. If you have any queries, leave in comments or mail me so that I can check and I reply. See you in next coming lectures. If you like my videos, please subscribe to my channel.